Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. In today's session, we will be seeing about the use of pointers with arrays and strings and the storage classes that are available in the C language. Pointers and their use with arrays, their use with strings, the concept of void pointers and storage classes. So, how is a pointer understood by the compiler when it is used with arrays? We already know what is an array. An array is nothing but a sequence of elements of the same data type stored in continuous memory locations. So, the array name itself resembles a pointer. So, when we say character array 1 and we define the size of the array, that itself refers to the first memory location that holds the first element. So, an array name itself is equivalent to a pointer or the address that points to the first element of the array. So, as I said, when I say data type, array name and the size of the array, that name itself represents the first element of the array, the place where it is stored. And array elements are always stored in continuous memory locations. So, this is how an array name itself is treated as a pointer in C. So, now we are going to see a program to copy the elements of one array into another using the concept of these pointers. And the difference is that when I am copying the elements from one array to the next, I want it to be copied in the reverse order. Like I want the last element of the first array to be the first element of the second array. So, this is done very easily using the pointer concept. An array itself is treated as a pointer. So, we will see how by manipulating the addresses we can easily reverse the elements of the array and store it in another location. So, as all programs, this also starts with the main function. I am having 2 arrays of type integer. Array 1 is the array which I want to be copied. So, this is array 1. I have already initialized the values of this array. It is in the descending order from 15 to 11, and this is the second array which is a duplicate one. I want these elements 15 to 11 to be copied into this array 2 in the reverse order, that means from 11 to 15, and I have an integer I to access the index. Index is nothing but it refers to the position of an element in the array. So, we will see how this program proceeds. I am just printing original array and duplicate array, and now I am having a for loop. In the for loop, I am using this integer variable which is nothing but to access the index of the array. I am checking the condition whether it is less than 5, because an array contains 5 elements according to my initialization, and when it contains 5 elements the index is from 0 to 4. So, I am checking whether it is less than 5, because 4 is less than 5, and each time the loop iterates I am incrementing the value of this I by 1. This is to move to the next element of the array, and here I am opening this brace for the for loop. So, the scope, that is the number of statements that are to be executed in the for loop, is controlled by this opening brace. So, this is the most important step which copies the elements of the array. Now, during the first time the loop iterates, the value of I is 0. So, the first element of the second array, the value is given by array 1 plus 4 minus I. So, now how does this manipulate? This array 1 is the address of the first element of the first array, plus 4 is, now say it is at position 2000 or 20. 20 plus 4 goes to the last element of the array. So, here in the first element of this duplicate array, I am copying the last element of the first array. Now, this is what I wanted. I want the elements to be arranged in the reverse order. That means, the first element of my duplicate array should be the last element of my first array. Now, this is how it goes in the output. 11 comes over here. How am I able to access it? By using this pointer. I am adding the addresses to the maximum and decrementing the previous value. So, during the first iteration the value of I is 0. So, the first element of the array, the address where it is stored, plus 4, that means it goes to the last element, the last address, minus 0. So, during the first iteration the last element of array 1 becomes the first element of array 2, and I am printing it over here, array 1 of I and array 2 of I. During the next iteration, I becomes incremented by 1. So, now we move to the second element of the original array, and this array 2 of I moves to this 12. So, what should be present in the second element of the duplicate array? What will be present? Array 1 plus 4. Now, this I now becomes 1. So, minus 1. So, if the values are stored from 20 to 24, I want what is stored at 24 to be stored in the first position, what is stored at 23 to be stored in the second position, 22 in the third, 21 in the fourth and 20 in the fifth. This is how the values can be reversed. Now, that is why I am adding this array 1 plus 4 and subtracting this minus I in every iteration. So, array 1 is 20 plus 4 minus 1, that means 24 minus 1, 23. So, what is stored in 23 over here? 12. So, this 12 moves to the second position of the array, and I am printing the values. Next iteration, I becomes incremented to 2. So, array 2 of 2, that means 0, 1 and 2. Next I am going to copy the element to the third element of the duplicate array. So, what should be present in the third element? Coming from the reverse, 13 should be present. So, again 20 plus 4 minus 2, that means 24 minus 2, 22. So, this 13 goes to this third position. The values are displayed. Again I is incremented by 1. So, now the value of I becomes from 0 till 1 to 2, now the value of I becomes 3. So, 20 plus 4 minus 3, 24 minus 3, it becomes 21. So, whatever is there in the first position gets copied to this fourth position. And finally, during the last iteration, what is there in the first position gets copied to the last. So, this is how, by manipulating the addresses of the first array, accessing the value using the pointer, I am storing whatever was stored in the ordinary order in the reverse order in this second array. So, when the array is displayed in each iteration, you can see the elements in the reverse order over here. So, this is just a normal logic using pointers to reverse the elements of an array and not to make the changes visible in the original array, but to copy it into a different array with a different name. This is how pointers are used with arrays. Next we will see how pointers are used with strings. Now, generally when we say a string, we know that string is nothing but a character array. Just now we have seen how arrays are used with pointers. So, the same concept is used with strings also, because string is nothing but a sequence of characters stored in continuous memory locations with a single variable name. So, here in this program we are beginning the program with the main function. I am having a string which is given the name NAME. So, character name of 15 characters I can store, that is the size of the array, and I have given pointer CH. So, this is nothing but the pointer variable which is of type character. So, this is a pointer variable of type character, this is a string of type character, the name of the string is name itself. So, first I have to enter some value, isn't it? Only then I can store that value at that particular memory location. So, for that reason I am printing F enter name and I am getting the string name. So, whatever name I enter, it will be stored in this character array. Now, the next step is the most important step of this program. Now, here is where I am assigning the address of this name, the base address where the name is stored, to this pointer variable CH. Here if you see, I am simply saying name is equal to CH. Now, how can I do this? How can I assign simply a string name to a pointer variable? This also holds the address, an array also holds the address. A string is nothing but an array of characters. So, when the compiler sees this kind of a statement, it understands that the base address means a starting address where the string's value is stored, is automatically assigned to this CH. So, the next time I use the variable name CH, it will automatically identify the string that is stored. Now, this is how pointers are used with strings. You do not have any special syntax for this, both are used to hold the address. So, by simply assigning the value of a string to a pointer variable, we can manipulate the addresses. So, next what I am going to do, I am going to check whether there is any value there. So, to check for the value I have to use the indirection operator. So, that is why I am using this pointer ch, checking whether there is any value there or whether it is a null character, because we know every string ends with a null character. As long as there is no null character, I am printing the value of this ch and the output comes over here. So, each character is printed as such, the address is incremented each time and the value that is stored at the address is checked. So, once the R alphabet is reached, it is displayed. After R there is nothing, that means it is null. So, when the address is incremented, there will be nothing present in that location, that address will be holding a null value. That is why the value is checked for null. If the value is null, it will come out of the while loop and it will end the program. So, this is how pointers are manipulated with strings. So, a pointer is nothing but a variable that is used to hold the address. An array is also a variable which holds the address. Only thing is, the array name points to the first element, the address of the first element in the array, whereas a pointer variable is used to hold only one address at a time. An array name can hold a sequence of addresses, and by just incrementing the array address each time, you can access the next variable of the array. And the position of each element in the array is represented by its index. So, this is how pointers are used with arrays and strings, and this is how the syntax is to be followed. Next we move over to this concept of void pointers. Now, what is the meaning of this word void? Void means null, that means there is nothing meaningful in it. Generally when we say functions, we have seen already, when the function returns a certain value, then it is said to have an integer type or a character type or a float type. But when there is no return value from the function, it is said to be of type void. So, similarly in pointers, when a pointer variable's data type is known, it is simply called a pointer. But when a pointer variable's data type is not identified, it is called a void pointer. So, the features of this void pointer is that it cannot be dereferenced without explicit type conversion. Dereference in the sense getting the value. So, you cannot get the value of a void pointer unless you explicitly mention its type and convert the value to that particular type, because its data type is not known. The compiler cannot detect the size of the object that the pointer points to. See, when we say integer or when we say character or when we say float, each of them have a certain storage bytes allocated by the compiler. So, unless the pointer is identified as pointing to an integer variable or character variable or float variable, the compiler will not be able to identify what is the size of the object to which the pointer is pointing to. And void variable declaration is not allowed. That means pointers can be void, but simply variable names cannot be void. I cannot simply give x. I have to give int x or character x or float x, but simply I can give void pointer x. So, these are the main features of pointers. What is the use of these void pointers? We will see after the break. Welcome back after the break. So, we had been seeing about the concept of void pointers. Void pointers are nothing but the data type of the variable that the pointer points to is not known. So, we cannot dereference the value of that variable, what it is pointing to, neither can we detect the size of the object it is pointing to. And one important feature is that only pointer variables can be void, simple variables cannot be declared as void. So, we will see an example program of how void pointers are used. Now, here if you see, I am having 3 variables of type integer, float and character, and I am having one pointer variable of type void, and I am assigning first the address of this integer variable to the pointer variable. So, here is where I define the type of the pointer variable. Here if you see, it is void. So, void star pointer variable pt. Here I am assigning the address of this integer variable p to this pointer variable pt. So, here the compiler will understand that this pointer variable is pointing to an object of type integer for which I am supposed to allocate these many number of bytes. So, from this itself you can understand that when a pointer variable is void, you can use that variable to hold the address of any type of general variable. It can hold the address of an integer or character or float according to the need of the situation. Now, that is one advantage of void pointers. Now, if you see, all these are declared before the main function. So, the first three statements are declared outside the main function. So, we have seen they are called global variables. They can be accessed throughout the program, they will be active. So, after this I am declaring the main function, and inside that, now here if you see, this is only explicit type conversion. I am dereferencing this pointer variable pt and assigning a value 12 to it using this explicit type conversion. We have seen what is type conversion, explicitly defining the type of the result that we want, or the type of the data type of the result that we want. The value of the variable should be displayed in this particular data type, that is only called explicit type conversion. So, here integer pointer pt, that means I am going to assign a value to this pointer variable that should be explicitly of type integer, and here I have already assigned the address of an integer variable to this pt. So, now the value that is being held by this pt is 12. So, then I am printing the value simply p. How am I printing simply p? Pointer pt is 12 means the address of p is held by pt. So, automatically this 12 will be stored in this variable p. So, this is how void pointers are used. Here I am giving the keyword void, that means I am not indicating any data type. Here I am explicitly telling that this pointer pt should hold the integer value. So, when I say pt should hold the integer value, automatically this integer value will be assigned to this variable p, because the address of p is only being held by this pt. Now, in the next step, if you see, I am doing explicit type conversion, float star pt is equal to 5.4. So, here it is a float value, I am explicitly converting it to this pointer variable of type pt, and I am converting this void pointer which was so long holding an integer value to hold a float value. So, this is the use of pointers. Now, if I had not declared this to be a void pointer, I need to have had an integer pointer variable, a float pointer variable and a character pointer variable to access each of these memory locations. But here I have declared only one pointer variable, and I am converting that pointer variable to a type integer, to a type float and to a type character. So, this itself I am efficiently using the memory space and the use of variable names also. Just in the last line we saw that this was used to display an integer value. Now, in the next line I am converting this pt to hold a float value and I am giving the value, and then I am printing the value d over here. Next, I am making this pt hold the address of a character variable. C is the character variable that we had declared, and I am explicitly type converting this pt to character star, and I am putting this s in this pt pointer variable. Then I am displaying the value of c. So, using the single pointer pt, I am making it hold values of 3 different data types. I am making it point to 3 different memory locations using the same variable name, and I am printing the values of 3 different types of variables. So, this is the use of void pointers. So, void pointers can be used to point to different types of variables at different points in the program. Because it has been globally declared, the variables will be visible throughout the lifetime of the program. So, this is the concept of void pointers. And finally, if you see, the output is displayed over here 12, 5.4 and c is equal to s. The only thing that we need to remember here is, before we explicitly type convert, we have to assign the address of that particular variable to pt. So, first we are assigned the integer address to pt, next the float address to pt, next the character address to pt. Only then we should explicitly type convert, otherwise the compiler will not understand. It will think so long it was holding an integer variable, how suddenly I can convert it to float. So, before you convert to float, you have to put ampersand d is equal to pt. Before you convert to character, you have to put ampersand c is equal to pt. So, these are points to be remembered when we are using a single void pointer to hold variables of different data types. So, this is all about pointers, their features, the use of pointers with operations, arithmetic, unary and binary, use of pointers with arrays and strings, and pointer to pointer concept and void pointer concept. Now, we will be looking into the storage classes in C. So, why have these storage classes come along with pointers? Storage classes refer to the amount of storage that is required for different types of variables that are declared in C. So, storage classes also are used for efficient manipulation of the memory space. So, why these storage classes are needed? What is the importance of these storage classes, and in what way it makes the user program more efficiently the memory space that is available in the C programming language. So, first before we begin with storage classes, we need to know what is the scope of a variable. The scope of a variable is defined as the area or block or part or subset of the C program from where a variable can be accessed. So, when you wish to access a variable, you should be in a position to identify whether in this particular set of statements I can access this variable, or whether I cannot see this variable from this function, whether I can see the variable from this function. So, the place where the variable is active or visible or accessible, that is called the scope of the program. Now, the types of storage classes that are available in C are function, whether the variable is accessible in this particular function, whether it is accessible in a particular file, whether it is accessible in a particular block means a subset of the statements, and function prototype of storage classes. Now, we will be seeing in detail what are the different types of variables that are used based upon the accessibility of the storage classes. So, what is the significance of the storage class? What does it tell the C compiler? It tells the C compiler about the storage area of the variable, that is, if a variable is starting to be stored at a particular memory location, how far is its storage area, the extent of its storage area. Suppose the variable's value is not been given initially by the user, it will initialize the value of that variable also. See, mostly when we use C programs, when you are manipulating some arithmetic value, say integer a, you just leave it like that, but later in the program you say a is equal to s plus c. Initially that variable a should be initialized to 0, otherwise the compiler will allocate some garbage value and you will not get the actual result that you want. So, every time you declare some numerical value in the program, it is always better to initialize its value to 0 or whatever value according to your need before you use it in the program. In case where the programmer forgets to give some initial value, the storage class itself will direct the compiler to give an initial value. That is another work of this storage class. And it tells about the scope of the variable, where the variable is accessible or visible, and the life of the variable, how long the variable is active. Now, this we have already seen with functions. If you declare a local variable, it is visible and active only in that particular function. Once you come out of the function, that variable is assumed to be inactive or no longer in use. So, all these features of the different variables that are used in the program, they are dictated by this storage class. So, all this information is given by the storage class to the C compiler, which makes it easier for the compiler to detect errors and compile the program. So, there are 4 types of variables defined by the storage class of C: the automatic variables, external variables, static variables, register variables. So, we will see the features of each of these variables in detail. Actually, most of these variables are what we have already used so far in so many programs. So, now we will see what is the significance of using those variables, why in certain places we use automatic variables and why in certain places we use the other types. These automatic variables are also called auto variables. They are the most commonly used variables in the program. They are the default type. If you simply give data type and a variable name, they mean it is an auto variable. It is defined inside a function. They are not defined outside function. So, automatic variables are mostly local variables only. They are available only to the current block or function. They cannot be accessed by the other functions. So, generally a common variable defined in the C program is an automatic variable, also called auto variable. They are local variables. They have to be defined inside a function. So, they should not be declared outside the main. All automatic variables should be declared within the main function. These are the features of these automatic variables. From the definition itself, you will understand that this is the most commonly used type of variables in C. Next, you have external variables. Now, these external variables are also called global variables. We already know what are global variables. Variables that are declared outside all functions, which are available throughout the entire program, can be seen by all the functions, accessed by all the functions, are called global variables. So that is a feature of these external variables. They are available to all the functions. They are declared outside the function body. So outside the main function they have to be declared if they are to be accessed by all. Now when global variables are declared, it is possible that we can have local variables also of the same variable name. So if I am saying integer x outside the main function, inside the main function also I can have an integer x in one of its sub functions. So in that case, when there is a conflict between the global variables and the local variables, I am having a global variable with the same name x, I am having a local variable inside one of the functions with the same name x. In that case the compiler will hide the use of the external variable and the priority will be given only to the local variable. That is what is mentioned over here. In case of conflict in variable names, priority is given to the auto variable. The global variable will be hidden. After that, because the local variables work will be over once it is outside the function. So once a conflict arises, the compiler will not give an error, it will simply give the preference to the local variable. Static variables can be internal or external type based on where they are declared. And when you say static variable, its contents remain constant, that is you cannot keep initializing its values again and again, only once its value can be initialized. And any change or updation that is made to the static variable in the program remains the same till the next time that variable is used for execution. So the last change made in the value of the static variable remains constant throughout the program. So when you want some variable to keep holding its value till you come back to it or till you refer to it again, you go in for this static variable. So the syntax is given here. Data type, you have to use the keyword static and you have to use the variable name. The last type of variables is register variables. These variables are stored in the CPU registers. We all know registers are temporary storage memory space. Their size is limited, they are limited in number also. So you cannot declare many variables of type register, only which is ultimately in need and very essential for fast execution. Only such variables you will use to store in registers. And suppose you, without your knowledge itself, you are going on storing numbers in the registers, the CPU itself, automatically the compiler will convert them to auto variables and store them in the computer's memory. So it will not lead to an error. So as long as you require, you think it is essential, you can declare variables to be of type register, because their execution speed will be fast, it is easier to access those variables. And the syntax for this register variables is register, keyword, int is the data type of the variable and the variable name. So this is how you declare the different types of variables in C. So the possible questions that can arise from this session are: how are pointers used with arrays and the pointers with strings, the different types of storage classes in C, and why the register storage class does not support. Register storage class is actually a 16 byte registers only. So generally when you try to store float and double values, the space will not be sufficient to store those values in registers. So that is why register storage class supports only integer and character type. Now even if you declare a float variable to be of type register, the compiler will not store it in register, because register can hold only maximum of 16 byte registers. So they are not big enough to hold float and double values. And static and external variables, we know their features. External are global variables, static variables may be internal or external based on their declaration space, and global variables can be modified anytime throughout the program, they are not constant. Static variables can be initialized only once, the last change made to it is the final change that is made before that program is called again or that variable is updated again. So in today's session we've seen about pointers with arrays and strings and the storage classes in C. So here we need to know what are the advantages of each of the type of variables when we use them in the program, and in what situation a compiler leads to an error. Sometimes a compiler will automatically identify certain mistakes made by the programmer and it will take alternate actions. In that case, it is sometimes difficult for the programmer to check where the error actually has occurred. So we need to know what all the compiler is capable of doing on its own, so that we will be able to think like it and detect the errors in the program, so that we get the expected results. So, these are the concepts of pointers and the storage classes used in C. Thank you.